Okay, so the start of exponent laws, first we're just going to look at what exponential form is, expanded form, and how we evaluate it. The reason that we're reviewing all this, so we did do exponent laws in grade 9, but we're going to look a little bit more at exponential form and some of the applications of it this year. So if we see something like 2 to the 4, what that means is 2 times 2 times 2 times 2. And if we were to evaluate that, you can either do 2 times 2 times 2 times 2, or you can put 2 to the 4 into your calculator and you can get 16. Okay, that one's not too hard to do, but if you get bigger numbers like 2 to the 30, you don't want to do 2 times 2 times 2 30 times. It gets a little repetitive and you might forget how many times you've done it, so you want to learn how to use your calculator. Okay, just looking at a couple quick rules. So something like, if I were to write these in expanded form, so writing in expanded form and then evaluating. So what that means is we're going to have negative 3 times negative 3 times negative 3 times negative 3. Now, that's going to be the same as negative 3 to the 4, which gives us 81. Now this next one's actually a little bit different, because if we were to do BEDMAS here, we have to do brackets, then exponents, then multiplication, then division. What this is actually saying is there's a little bracket there. This says negative 1, or just negative, times 3 to the 4. So really what this is negative 3 times 3 times 3 times 3, which is negative 81. So if it's inside the brackets, if the negative's inside the brackets, then that's included in our exponent. If it's not inside the brackets, like this one, then it's not included in our exponent. And we just do 3 to the 4 and then change the sign and make it negative. Okay, looking at this next one, it would be negative 3 times negative 3 times negative 3. And now that's going to be 3 times 3 is 9, times 3 is 27, and then 3 negatives is going to make it negative 27. A negative and a negative becomes positive, so the first two would be positive, but then a positive and another negative becomes negative again. So what we're doing is any even amount of negative signs is positive, any odd amount is negative. And looking at this one, we've got 3.5 times 3.5 times 3.5 times 3.5. Again, I'm just doing this in my calculator, and I'm getting 150.0. Oh, that looks like a 6, and the next number is actually a 6. Alright, now finally, this one would be 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3, which is going to give us 2, 4, 8, 16 over 81. Now there's actually another way we can do that last one that's a little bit useful when we get a little further along. So we've got 2 over 3 to the 4. We could actually write that as 2 to the 4 over 3 to the 4. Well, that's 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3. So still get the same answer, but we've written it a little bit differently. This exponent goes on the bottom and top, so we need to remember that for later on. Alright, so next, what we're looking at here is we're looking at what's called the product rule. We're multiplying things that have the same base. So if it has the same base, we're going to be able to use the product rule. If it doesn't have the same base, we just have to actually do the exponent and then multiply or add it together. Okay, so looking at this, what this would say in expanded form is 3 times 3 times 3 times 3 times 3 times 3. Well, if we wrote that as a single power, there's really 1, 2, 3, 4, 5, 6 threes. So this is 3 to the 6. Okay, the next one 2 to the 3 is 2 times 2 times 2, times 2 to the 5 is 2 times 2 times 2 times 2 times 2 times 2. Well, here there's 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. So we have 2 to the exponent 9. Okay, now kind of a general case, we can do this with variables as well. We've got 3k's, k times k times k, times 5k's multiplied together. So now, wow, that's a lot of lines. Now we actually have 8k's in total, k to the 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so in general, the way we write this is a to the n times a to the m, so a to some exponent times a to some other exponent equals a, the base doesn't change, and all we do is add the exponents. Okay, now the next one, what we're looking at is the opposite. We're actually dividing now. So the way I'm going to do this is I'm going to write it as a fraction. Okay, so we know that division can be a fraction, so we know that this is actually equal to 3 to the 5 divided by 3 to the 3. This is 2 to the 7 divided by 2, and that would be actually to the 1. And this is k to the 8 divided by k to the 5. Okay, now the reason I'm going to write that, we know that 3 to the 5 is 3 times 3 times 3, 5 times, all over 3 times 3 times 3. Well, what we can actually do here is we can simplify this down. So one of these 3's, because it's all multiplying, can cancel with 1 on the top and 1 on the bottom. And so what we're left with is 3 squared. We're only left with 2 3's on the top. Okay, same thing here. 2 times 2, 3, 4, 5, 6, 7, all divided by 2. That 2 and that 2 can cancel, and we're left with 2 to the 6. Now when these cancel, they all become 1's. 3 divided by 3 is 1 over 1. 3 divided by 3, 1 over 1, 1 over 1. Okay, so on the bottom, really what we have is 1 times 1 times 1. On the bottom here, really we have a 1. Okay, so we have 2 to the 6 over 1, which is the same as 2 to the 6. Okay, here we've got k, 2, 3, 4, 5, 6, 7, 8. Wow, I should have made these numbers smaller. 1, 2, 3, 4, 5. Okay, now I'm going to switch colors here just to make sure we can see it. Those cancel out, those cancel out, those cancel out. And I'm just canceling until I'm left with k to the 3. So what we should be noticing here is if we have a to the n divided by a to the m, we still have the same base, but we're actually subtracting the exponents. Okay, now there's one last thing I'm going to quickly show you here, is if we have something like, so a lot of this comes up often, what if we have something like 2 to the 3 divided by 2 to the 5? Well, 2 to the 3 divided by 2 to the 5, well, that would be 2 times 2 times 2, all divided by 2 times 2 times 2 times 2 times 2. Because if I do 3, and what that's going to leave me is we're canceling out, and we get 1 over 2 squared. Okay, because if I actually divide those, or use that rule that I just said, subtract my exponents, this would tell me that I get 2 to the negative 2. Well, 2 to the negative 2, all we have to do is flip the side of the fraction that it's on. If it's negative, it's on the top of the fraction. This is really 2 over 1. We flip the fraction and make it positive, just because of what I just showed you. Okay? If you ever get a negative exponent, just put it on the other side of the fraction. If it's not a fraction, make it 1 over that value. Okay? The second thing I want to show you really quickly is, what if we get an exponent 0? Okay, let's explain why the exponent 0 is always equal to 1. Anything to the exponent 0, any number at all. 3.268 to the exponent 0 is 1. 2,942 to the exponent 0 is 1. The reason that is because of this rule. The rule right here. Okay, it's a very important rule. If we have 2 to the 3 divided by 2 to the 3, well, what that's going to say is our rule gives us 2 to the 0. Okay, 3 minus 3 is 0. But if we were to put it into long form, what we actually get is 2 times 2 times 2 divided by 2 times 2 times 2. These cancel, these cancel, these cancel, and I'm left with nothing. I'm left with 1 over 1. 1 over 1 equals 1. So then what that's saying is 2 to the 0 equals 1. And it will work the same for any question you do like that. Okay, there's a couple worksheets associated with this one.